Hello everyone, welcome to this video. In this video, we are going to look at two important theorems related to the distribution of dataset. The first rule is called the Chebyshevs Theorem. The statement for this theorem is the proportion of values from a dataset that will fall within k standard deviation of the mean will be at least 1 minus 1 over k squared times 100%, where k is a number, not necessarily an integer, greater than 1. Let's try to understand this. So for this, what I'm going to do is I'm going to draw a data distribution here. Suppose along the y-axis, you have the frequency for the distribution, and along the x-axis you have the variable x. Now suppose that the distribution of the data is something like that. Okay, that is the distribution of the data. You can clearly see that the data distribution is not normal. Suppose the mean of the distribution is here in the middle. Say for example that is mu. Now if I go k standard deviation above the mean, that is, this is equal to mean plus k standard deviation, k times sigma. And if I go down the same amount here, this is mean minus k standard deviation. So if you want to find the proportion of data that lies within this region here, the proportion of the data that lies within this region is at least 1 minus 1 over k squared times 100%. So this will give you the minimum amount of data that lies within the given standard deviation. For example, in this figure, we have the data that lies within the k standard deviation. For example, if I want to find the amount of data that lies within 2 standard deviation from the mean, we substitute k equal to 2 in the above equation. So here k will be equal to 2. Okay, let's plug in that value. So what we get is 1 minus 1 over k squared. K is 2, so 2 squared is 4, times 100%, which is equal to 1 minus 1/4 is 3/4 times 100%. So that is 3/4 of 100%, which is 75%. So that is 75%. So you can say that the 75% of the data lies within 2 standard deviation of mean. That is the minimum amount. So approximately 75% of the data, or at least 75% of the data, lies within 2 standard deviation of the mean. Let's find out how much data lies within 3 standard deviation from the mean. So in this case, k is equal to 3. If we plug in k equal to 3 in the above formula, we have 1 minus 1 over k squared, 3 squared is 9, times 100%, which is equal to 1 minus 1/9 is 8/9, 8 over 9 times 100%. 8 over 9 times 100%, which is same as if we multiply 8 times 100, that is 800. 800 divided by 9 is 88.89. So 88.89, or at least 88.89% of the data lies within 3 standard deviation of the mean. So this is the principal idea behind Chebyshevs theorem. So the Chebyshevs theorem gives you the minimum amount of data that lies within k standard deviation, and that amount is 1 minus 1 over k squared times 100%. Remember that k is any number which is more than 1. Now we are going to look at the example associated with the theorem. Okay, here is the example. The average bill amount at local restaurant in Aurora, Colorado is $37.53 with a standard deviation of 7.10. So they have given the mean 37.53 and the standard deviation 7.10. We have to find what is the minimum percentage. Whenever we are asked to find the minimum percentage, you must think of the Chebyshevs theorem, because the minimum percentage will be 1 minus 1 over k squared times 100%. So what is the minimum percentage of bill between 23.33 and 51.73? So let's try this. They have given mean, so I'm going to put the mean in the middle, okay, which is 37.53, and the standard deviation is 7.10. So if I add 7.10, the value will be 44.63, 44.63, so which is 1 standard deviation above mean. If I subtract that, the value will be 30.43, 30.43. So 30.43 up to 44.63, this is the amount of data within 1 standard deviation. That is, from the previous theorem, we know that the amount of data that lies within this one, within 1 standard deviation, is 75%. But here in our problem, we have to find from 23.33 up to 51.73. So let's go 1 standard deviation up. 44.63 plus 1 standard deviation, or 7.10, is, if I add that, it is 51.3. And then if I go 1 standard deviation down, 30.43 minus 7.10, that will be 23.33. 23.33. So from 23.33 up to 51.3, okay, 51.73 in fact, 51.73, 23.33 up to 51.73, the amount of data that lies here is the data within 2 standard deviation. So this is your mean. That means this is mean minus 2 standard deviation. Okay, mean minus 2 standard deviation. I can write that. Mean minus 2 standard deviation. And this side it is mean plus 2 standard deviation. Your distribution can be any. So we are looking for the amount of data that lies within that. So what is the probability that the data falls within this, the minimum? Okay, so what we have to do according to the Chebyshevs theorem, so within 2 SD, or within 2 standard deviation, the amount of data within 2 standard deviation is given by the formula 1 minus 1 over k squared, that is 2 squared, okay, 2 squared times 100%. So that is equal to 1 minus 1/4 times 100%. 1 minus 1/4 is 3/4. 3/4 of 100%, or 300 divided by 4, which is equal to 75%. So we have a minimum of 75% of the data that lies between 23.33 and 51.73. So you can say at least 75% of the data lies between $23.33 and $51.73. So this example illustrates the example or application of Chebyshevs theorem. Okay, the next theorem that we are going to explore in this video is the empirical rule. Chebyshevs theorem applies to any distribution. That is something we need to know. Chebyshevs theorem applies to any distribution regardless of shape. However, when the distribution is bell-shaped, or we call normal distribution, then we use the empirical rule. So remember, empirical rule is applicable only when the distribution is normal. When I say normal distribution, it is symmetrical or bell-shaped, where it has an equation to describe the distribution. For example, the equation for this graph here is, okay, this is quite interesting. It is f of x is equal to 1 divided by sigma, that is standard deviation, times the square root of 2 pi multiplied to e raised to the exponential function e raised to negative x, the variable, minus mean squared over 2 sigma squared. So the graph of this function here, it is a symmetrical graph or bell-shaped graph, and this is for normal distribution. Okay, this is for the normal distribution. So for the normal distribution, we use empirical rule, and what it says is this: approximately 68% of the data fall within 1 standard deviation of the mean. For example, here we have the mean plus 1 standard deviation, mean minus 1 standard deviation. We are in this region. So in this region over here, we have approximately 68% of the data. Okay, approximately 68%. And here is more accurate breakdown of the data. So 68 by symmetry, if you divide it into two parts, here you will see 34, here you will see 34. But this is more accurate value given here. If you just look at 34, that is still okay. 34%, 34%. Or more accurately, it is 34.13%. That is within 1 standard deviation. Now if you go 2 standard deviation up from the mean, from here, if you go 2 standard deviation up, and then from the mean, if you go 2 standard deviation down, then the amount of data that you will see here, okay, the amount of data that you will see here is approximately 95%. Okay, so if you want to find how much data lies here, for example, in this region, okay, this and this, they will be equal. If you want to find that, you can see that it's pretty easy, because the amount that lies here in the middle, okay, from here up to here, that is 68%. That is 68%. Plus this area here and this one here that we are looking for, these are unknown area. You don't know how much is that, but they will be equal. So you can consider them as x. If this is x, this is also x. So this x plus this x is 2x. Okay, equal to total area, because this area here plus this will give you the total value over here. So according to the empirical rule, it's 95%. So 95%. So you can solve this equation and find the value of x. So by solving that equation, we obtain x equal to 13.5. So amount of data that lies here is 13.5, or more accurately, you can see it is 13.59. But if you use 13.5, that's fine. 13.5. The rule talks about the approximate value. So approximately 13.5% of the data is here. Or within 2 standard deviation, you have 95%. Within 1 standard deviation, 68%. Within 2 standard deviation, 95%. Similarly, you can see within 3 standard deviation. If you go 3 standard deviation up from mean up to here, and 3 standard deviation down from mean all the way up to here, the total amount of data that lies within this region, okay, all this data will be 99.7%. 99.7%. So if you want to find this value, suppose if I want to find this area, okay, if I want to find this area, the area on the left and area on the right, they are equal by symmetry. So if this is x, that is 2x, and then within the 2 standard deviation, you already have 95% here. So these 95% plus this x plus this x. So 2x plus 95% plus 95% will give you the total area within 3 standard deviation, which is 99.7%. 99.7%. Okay, then if we solve this equation, x is equal to 2.35 by solving that equation. Meaning of that is this area here, okay, the amount of data that lies here is approximately 2.35. Empirical rule gives you the approximate value. So approximately 2.35. More accurately, you can see it is 2.15%. So that is the amount of area or amount of data that lies here, okay, using the empirical rule. Within 1 standard deviation from here to here, we have 68%. When you divide it into 2 equal parts, you'll get these values, 34%. Within 2 standard deviation, you have 95%. So this is 34%, this is 34%, you can see. This is 34%, so this will be 13.5% by using this calculation here. Within 2 standard deviation, 95. Now within 3 standard deviation, you have 99.7%. Within 3 standard deviation, you have 99.7%. So if you want to find this value here, we know from here to here, it is 95. Then these equal areas, you can say 2x, will give you the total area within 3 standard deviation, 99.7. By solving that equation, we get 2.35. So the amount of data that lies here is approximately 2.35. Finally, the amount of data that is below 3 standard deviation and above 3 standard deviation is 100% minus 99.7%, because the data within 3 standard deviation is 99.7%. So 100 minus 99.7% will be 0.3%. And when you divide that into 2 equal parts here, this area should come approximately 0.15, or more accurately 0.13. If we use 0.15, that's fine. 0.15% approximately. Okay, 0.15 approximately, that is the approximate value. Okay, or about 0.15%. That's why the values which are given more accurately are a little bit different from the values given by the empirical rule. So this rule is called the empirical rule. Empirical rule is used only for the normal distribution. The empirical rule will give you the amount of data that lies within 1, 2, or 3 standard deviation. Within 1 standard deviation, you'll have approximately 68% of the data. Within 2 standard deviation, you'll have about 95% of the data. And within 3 standard deviation, you'll have about 99.7% of the data. Now we are going to look at an example where we can use empirical rule. Okay, here is the example. Monthly Excel energy bill in Aurora, Colorado are distributed normally. So you can see this is the case of normal distribution with a mean of $250 and standard deviation $50. Now the question is, what percent of monthly bills are in the range of $200 to $300? So the first part, A, let me draw that normal distribution so that it's a little easy for us to understand. So suppose this is our normal distribution. We have mean in the middle all the time. Mean is 250. And we have the standard deviation of 50. So we go up by 50. So this will be 300. If you go down by 50, this will be 200. So you can see that for the first part, what percent of monthly bills are in the range of 200 to 300. 200 to 300 is this one, which is within 1 standard deviation. So this is within 1 standard deviation. And you know, from the empirical rule, the amount of data that lies within 1 standard deviation is 68%. So you can say that 68% of the data lies within this. So what percent of monthly bills are in the range from 200 to 300? 68%. 68% of monthly bills are in the range $200 to $300. So that is the answer to the first part. Now let's look at the second one. What is the probability that randomly chosen monthly bills or monthly bill is less than $150? Okay, is $150 or less. One more time. What is the probability that randomly chosen monthly bill is $150 or less? Let me draw the probability distribution for that. So we have the mean 250 in the middle. So if we go 1 standard deviation up, $300, 2 standard deviations up, $350, 1 standard deviation down from mean, $200, 2 standard deviations down from mean, $150. Here the question is, what is the probability or what is the percentage? We can also write like this. We have to find the probability. Okay, what is the probability that randomly chosen monthly bill is $150 or less? So the monthly bill X is less than or equal to $150. What is this equal to? So less than 150 is this area. So we have to find what is that equal to. So what we know is the data from here to here is within 2 standard deviation. So the amount of data that is within 2 standard deviation is 95%. In terms of probability, that is 0.95. Probability is the decimal value. So the total is 1. Total area is 100%. Okay, total area under this curve is 100% or 1. 1 minus, if I subtract this area in the middle, 1 minus that 95%, 0.95, I obtain this area on the left plus this area on the left, right. These two areas are equal. So if I just want the area on the left, I have to divide these two. Okay, I have to divide these two equally. So divide this by 2. And by dividing this, what we get is 0.025. You don't have to change these to percentage because we are talking about probability. When you're working on probability, we write as decimal. When you're asked to write a percent, you just leave it that way, 68%. So the answer for the second part, B, is the probability that the monthly bill is less than or equal to $150 is equal to 0.025. So this is the use of the empirical rule. And this is the end of the video. We work on two important theorems, Chebyshevs theorem, which is for any distribution, and the empirical rule, which is exclusively for the normal distribution. I hope this is helpful. Thank you so much for watching.